Thank you for clicking this video. I hope you're really interested in learning some basic concepts in chemistry. And if you want to stay connected, you can click the subscribe button below so that you will catch up for more channel uploads. In this video, we will discuss the very basic topic in chemistry: stoichiometry. It is all about calculating the mass relationship of compounds, elements, and atoms in a chemical reaction. This is very important in the entire chemistry course. So if you're a chemistry major, you can learn some technique in solving problem here, and stay tuned. First of all, we have to take note of some chemistry terms and its definition. Starting with the atomic mass, sometimes called the atomic weight, is the mass of an atom in atomic mass unit, or AMU. You can find it in the periodic table, in each element. For example, hydrogen is 1.008 atomic mass units. But atoms have really small masses, and there's no device to weigh them in units of AMU. In reality, we deal with macroscopic samples that contains enormous atoms. To describe or express this large number of atoms, mole is used to measure the amount of substance, which has several number of atoms, molecules, and other particles. Experimentally, it was determined that each mole of a substance has 6.022 times 10 to the 23 atoms. This is called the Avogadro's number, in honor of the Italian scientist, Amedeo Avogadro. In the continuation of his experiment, it was found that molar mass is equal to grams of 1 mole of unit. Basically, this is numerically equal to the atomic mass in AMU. To apply this concept in problem solving, here's an example. Helium gas is valuably used in industries. How many moles of helium atoms are in 8 grams of helium? It is given in the periodic table that helium has a molar of 4.003 grams. This can be used in converting grams of a substance to the number of moles. Starting with the given, the amount of moles of helium is equal to 8 grams divided by 4.003 grams per mole. This is equal to 2 moles of helium. Another important term is the percent composition of compounds. When you're already familiar with the concepts we talked earlier, it is easy for you to understand and solve different problems regarding the percent composition of compounds. In analytical chemistry, data are obtained experimentally, perhaps using some analytical instruments, or by classical method of analysis. Also, the formula of a certain compound can be obtained by an analytical instrument. But in solving chemistry problems in your class, data are given, so no need to worry. The percent composition by mass of an element in a compound is equal to the number of moles expressed in N, multiplied by the molar mass of an element, divided by the molar mass of the compound, times 100. For example, in hydrogen peroxide, there are 2 moles of hydrogen atoms, and 2 moles of oxygen atoms. The percent composition of hydrogen is equal to 2 times 1.008 grams, the molar mass of hydrogen, divided by 34.02 grams the molar mass of hydrogen peroxide, times 100, and is equal to 5.926%. Same calculation is done for oxygen atom. If we know the percent composition of a compound, the empirical formula can be obtained. It is the simplest whole number ratio of elements in a certain compound. It is not the total number of atoms of an element in a compound, it just shows the ratio. Here's an example. Ascorbic acid or vitamin C cures scurvy. It consists of 40.92% carbon, 4.58% hydrogen, and 54.5% oxygen by mass. What is its empirical formula? First, we have to assume 100 grams of ascorbic acid sample is present, so that it will be easier to convert percentage to grams. Next, calculate the number of moles, denoted as N. Then, divide the smallest number of moles to convert to whole numbers, as the subscripts. In this case, hydrogen atom is approximately equal to 1.33. We want to convert this to whole number. By trial and error we can multiply whole numbers and see if it will result a whole number. Multiplying by 3 will give 3.99 and can be rounded to 4. As a result, all subscripts in each element are multiplied by 3. This gives the empirical formula for ascorbic acid is C3H4O3. To calculate the actual molecular formula, we must know the approximate molar mass of a given compound, as well as the empirical formula. From the previous example, if the molar mass of ascorbic acid is given, which is equal to 176.12 grams per mole. Let's also determine the empirical molar mass, which is 88 grams per mole. Then, divide the ratio of the molar mass, and the empirical molar mass, which gives 2. Using this to determine the molecular formula, multiply all the subscript by 2 will give C6H8O6. I hope you understand the basic concept in stoichiometry. By practicing solving problems, you can master this topic and pass your exams, if you have in the future. Here are some sample problem that you can practice working on. Comment your answers and I'll let you know if you got it right.